In today's section, we're going to go over section 5.2, which is evaluate and graph polynomial functions. Now, here we're going to be covering five different types of polynomial functions, and they are all just based on their degree. So if you have a degree of 0, it is considered constant. And that right there is an example. Then there is a degree of 1, that's linear. Degree of 2, that's considered quadratic. A degree of 3, that's a cubic. A degree of 4, that's called a quartic. And here on the right side you would see examples of all of them. Keep in mind that when they're in standard form, you always need to put the largest exponent first. So when we look at example 1 and it's asking us to determine whether the function is a polynomial function, if so, we need to write it in standard form and state the degree and the type and the leading coefficient. So if we look at A, our biggest exponent would be who? 4 is correct. So if I had to write this in standard form, I would put f of x equals negative x to the fourth plus 2x to the third plus 1/2 x squared plus 3. Now, the degree is 4. Because it has a degree of 4, we call this a quartic. And your leading coefficient would be -1. Now let's go ahead and try the next one. Now on C, which is right next to it, we look at it, and would that be a polynomial? Some of you are probably thinking, well, it has a degree to the 5, but the question here would be, is this allowed? Can you have a negative exponent based on what we learned on 5.1 on, I think it's last Thursday? It's not allowed actually, so this is not a polynomial function. Now when we look at example B under example 1, we have 7x square root of 3. That is still a number, so that's considered okay, plus pi x squared. Now pi has a value which is 3.14 and it keeps going, so that is okay. So when we look at this, we're supposed to first put it in, decide if it is going to be a polynomial function, and the answer to that should be yes. My largest exponent is 2, and then we have an exponent of 1, and then we just have a number. So we're going to have to write this in standard form, and that would be this here. Pi x squared plus 7x plus the square root of 3. When we look at this, it is my degree is 2, because it is a degree of 2. It is what we called a quadratic. And then it's asking for your leading coefficient, which in this case would be a 3. I mean the pi, sorry, which is 3.14. When we look at D, k of x equals x plus 2 to the x plus 0.6x to the third. Now this x is good, this 0.6x to the third is good. But let's look at that. In any of the examples on the top, do we have x as an exponent? No. So this here would be just like C. This is not a polynomial function. Next example, it is evaluate by direct substitution. This is probably one of the easiest problems that we're going to do. These kinds of examples. Direct substitution. Well, we know substitution means it takes the spot of something. Direct, it just means do it without any hesitation. So here we have f of x. Now, this f of x once we put 3 to the 4th power in the calculator, we do get that that is 81. Minus 5, 3 to the 3rd power is 27. This basically stays the same because there's no power. So from here we continue. 2 times 81 is 162. Negative 5 times 27 is 135. And then this is a negative 12 and this is a plus 8. When you put all that together, or you put in the calculator, you will get that your answer is 23. That right there is direct substitution. In example 3, which we're going to evaluate by synthetic substitution, it's a little bit like what we did on on Monday, the second lesson that I did with you from 5.5, where you would do long division. First of all, you need to keep in mind that you do have both a degree, a number for every degree. So we see we have x to the 4th, x to the 3rd, but is there an x squared? No. So we would put just the 2. We would put the negative 5. But because there is no x to the 2nd, we would put a 0 for that. Then we would just put a negative 4 and an 8. Now, unlike what we did on Monday, we're actually having to just write the numbers without any of the coefficients. Now, here we're going to do something like this, and that 3 is going to go outside. Now, you're going to bring down the first number, which is your 2. 3 times 2 is 6. So what is negative 5 plus 6? Well, that is 1. Then you do 1 times 3, which is 3. 0 plus 3 is 3. Then we have 3 times 3, which is 9. Negative 4 plus 9, that would be a 5. 3 plus times 5 is 15. And then, what's 8 plus 15? 23. This is the same thing like what we did in example 2, except this is using synthetic division. The other one's by using direct substitution. The last number there, that would be your final answer. This here is just a table that you need to kind of feel comfortable with. Just by looking at a graph, you should be able to tell if it's odd or if it's even. Please look at the two odd ones. All they do is a little squiggly line that goes up and down. But because of their leading coefficient, which is either positive or negative, it just depends how it finishes. Like this one, that it's negative, it finishes down here. This one, because it's positive, it finishes where? On top. Now, the bottom ones, it's even. Now this one makes some kind of little W. So it's either one that's going up or down. If it opens up, it's positive. If it opens down, it would be negative. Now I'm going to give you an example, and then you let me know just by looking at it and keeping this in mind which one you think it is. So this one is an example that goes up and down. It doesn't make a W. So because it doesn't make a W, I should know my answer cannot be C or D. But where does it finish up on? On top or in the bottom? Up on top, so that should tell me my answer should be positive. So this would be A.